Hello to all my viewers. This is Dr. Dhaval Maheta, and today we will understand how to plot ROC curve in KNIME using neural network. Neural network use a variety of algorithms for training and making predictions, including backpropagations, gradient descent, and stochastic gradient descent. These algorithms involve adjusting the weights and biases of the neurons in the network based on the error between the predicted output and the actual output for a given input. During the training process, the neural network algorithm iteratively adjusts the weights and biases of the neurons to minimize the errors between the predicted output and the actual output. This is done by propagating the error backwards through the network, updating the weights and biases of each neuron based on its contribution to the error. Once we run the neural network algorithm, it is necessary to check its classification accuracy, and for this, we generate the confusion matrix. Now, what is this confusion matrix? Let's try to understand. On the original data, if a person is normal or a person is having a COVID, and we are using the kit to detect it. So, a person is having a COVID and the kit detected it that yes, the person is having a COVID, then it is a success. So, 50 cases are such where we got the success. Similarly, a person is normal and the kit detected that the person is normal. So 114 is also considered to be the success. So the overall success is 50 plus 114, 164. Now the misclassification has happened here. A person is normal, but the kit detects that the person is having a COVID. So 6 such cases are there. Similarly, a person is having a COVID, but the kit detected that the person is normal. So 22 such cases are there. So 22 plus 6 are misclassified cases. Now, AUC is a measurement of the overall performance of the classifier, which ranges from zero point 0.1 to 1. The higher the AUC, the better is the classifier at distinguishing between the two classes, which we have already seen. The accuracy of the test depends on how well the test separates the group behind being tested into those with and without the disease in the equation. Accuracy is measured by the area under the ROC curve. An area of 1 represents a perfect test, an area of zero point 0.5 represents a worthless test. A rough guide for classifying the accuracy of the diagnostic test is given below. If you get area under the curve between the range 0.90 to 1, it is an excellent model. 0.80 to 0.90, good. 0.70 to 0.80, fair. 0.60 to 0.70, poor. 0.50 to 0.60, fail. A receiving operating characteristics curve is a graphical representation of the performance of the binary classifier system such as a logistic regression, neo Bayes, disease entry, as its discrimination threshold is varied. The ROC curve plots a true positive rate against the false positive rate at various threshold settings. You can see here the dark diagonal line represents a point of the AOC of zero point 0.5, which is just a random guess, means there is no model. The idealistic situation is the when your curve overlaps the y-axis and x-axis. It's the idealistic situation. That is 100% classification accuracy. But normally this you will not get. So if we are having two models, one is in blue color and another is in red color. So the model which covers more area is a better model. So here the red color method one is a better model. Now how we can run ROC? Let's see in KNIME. So first of all, we'll go in the KNIME Analytics platform and I will activate input output from here. CSV reader. Double click on it. Browse the dataset. I've activated the CSV node as my file is in CSV format. Part 1, press open, click OK. Now, right click on it and execute. Right click on it and see the file table. I request my viewers to kindly refer the previous video to understand the flow of these tutorials. So there are many variables in this dataset. We are going to select few of them. So for this, I'll activate the column filter. Right click on it, configure, take all the variables on left hand side, only transfer age, resting blood pressure, cholesterol, maximum hours of exercise, and heart disease. Heart disease is our target variable. Click OK. Right click on it and execute. Again, right click on it and see the filtered table. Now, activate the normalizer as all these variables are on different scales. Right click on it, configure. Three types of normalizations are there, which we have discussed previously. We are going to use mean max normalization. Click OK. Right click on it and execute. After this, we will activate the partitioning. The data will be divided into training and testing data set. So partitioning. Connect this node from here. Right click on it, configure. 80% data for training, 20% for testing, and the sampling will be stratified based on heart disease. Right click on it and execute. Now activate the learner, the neural network learner. It's a multi-layer perceptron. It is known as a multi-layer perceptron learner, MLP. Activate it. Right click on it, configure. So we are only using one hidden layer. We can make it 2 and make sure that the heart disease is the target variable. Click OK, right click on it and execute. Now activate. You will not get any equation like regression analysis or logistic regression. Here you will only get the error plot. The desired thing is that this error plot should diminish. It should diminish. Okay. Activate the predictor from here. So this predictor will get its learning from here and the data set will be fed from here. Right click on it and configure. Change the production column name, heart disease, click OK. Right click on it and execute. Again, right click on it and you can see the classified data. So this is a prediction. Now we want to see how well the prediction goes. So for this, we'll activate the scorer. Right click on it and configure. Heart disease. Click OK. Right click on it and execute. Right click and you can see the confusion matrix. So 49 plus 77. Total is 126 cases are such in which the algorithm has correctly classified. The classification accuracy is 68%, which is considered to be quite low. Let's activate the ROC curve from here. Take this ROC curve here. Delete. Now I'll connect this ROC curve here. Right click on it and configure. I'll activate the heart disease. Activate yes from here. Transfer all other variables this side and only include the prediction heart disease. Click OK. Still you are having cross here. No need to worry. Right click on it. Configure. General plot options. Create image and plot. Click OK. Right click on it and execute. Again right click on it. And you can see the image. So the area under this curve, AOC curve is 0.721. So let's do the interpretation. So we'll write down here 0.721. An area value of 0.72 in ROC indicates that this is not a support vector machine. We are going to use this as, this is neural network. Neural network has a reasonable level of discriminative power in distinguishing between the positive and negative classes. An AUC of 0.731, let's change this to 0.721, suggests that the model does not have very good ability to correctly classify positive instances as positive and negative instances as negative. In other words, the model predictions are just better than the random chance, but there may be many misclassifications or overlap between the two classes. So this is how you can plot the ROC curve in KNIME. For more videos on KNIME, you can subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I already uploaded many videos on KNIME.